let's take a look at this new integral that says 3x to the power 4 minus 2x plus 7 over x squared. So again, as usual, we can separate the integral into multiple pieces. So we're going to do the 3x4 by itself into its own integral, the negative 2x by itself into its own integral, and finally the 7 over x squared, again by itself, into its own integral. Next, what we're going to do is pull the constants out. So first, I can separate because the rule is if you have pluses and minuses, you just ignore them, you do piece by piece. Next, we're going to take out the 3, the 2, and the 7 out of the integrals. So be careful when you take out the last 7. When you put it on the outside, you have to put a 1 in its place because the 7 was already on the numerator. Now, the first integral is ready to go. This one can be finished. The second integral is ready to go. The third one, however, is not ready because the x has an exponent that is a 2, and that x squared is on the denominator. So it's not convenient to leave it on the denominator. The only time we leave the x on the denominator is if you have 1 over x like we did in the last example. That is the only time we leave it on the denominator. Otherwise, we have to bring the x to the numerator. So let's do that next. We can do that using what's called the negative exponent rule. So you can switch the x from the denominator to the numerator as long as you give the x a negative exponent. And at this point, we are ready to integrate each of the terms one by one. So starting with the 3, we're going to leave it alone, and then we're going to look at the x to the power 4, the x, that whole thing with the antiderivative becomes x to the power of 5 because 4 plus 1 is going to be 5 divided by 5 as well. Now we have a negative 2, we're going to ignore, and we take a look at the x dx. The antiderivative of x dx, x has power 1 right here, so the antiderivative is going to be x to the power of 2 divided by 2. So we always add 1 to the power and divide by the same value. And then finally there's the 7, and again we have x to the power of negative 2, which means again we are going to be adding 1 to the exponent and dividing by the same thing. So if you add 1 to the exponent, negative 2 plus 1 is going to be negative 1, all divided by negative 1. And since we have an integral, we're going to put a plus c where c is a random number. Let's clean it up. So 3/5 and x to the power 5 minus 2 over 2 is going to cancel out. We just get x squared. Plus 7 divided by negative 1 is going to be negative 7. And the x has a negative exponent. You can leave it like right there as a negative exponent, or you can write it on the denominator if you wish. It's up to you. It doesn't really matter. So you can write 7 over x or 7x to the power of negative 1. I'm going to leave it like this to save time and call it a day. That's it. So with this problem, I used the power rule 3 times. Every single one of these problems, what I did here, was done with a power rule. Okay, so now we're ready to look at the next problem. And the next problem that we're about to do is similar to the one that is on top of this page, and it has a fraction. So again, with fractions, we're going to break the fraction apart into multiple pieces and give each piece the original denominator. So, 5x gets its own denominator, 9x squared gets its own denominator, and we will reduce the fractions to lowest terms, so divide them out as much as possible. And I'm gonna do the division, and I'm gonna do separation of integral all at the same time. So I'm gonna separate and divide. So separate the integrals because of the plus sign, and let's divide them out at the same time. So we're gonna have the first integral, we're gonna have a second integral, and the first integral is going to say the fraction 5 over 4 with an x on the denominator. The second fraction is going to divide out the x's, and we're going to end up with 9 over 4. So next, we're going to pull the numbers out of the integrals. So the first integral becomes 5 over 4 on the outside, integral of 1 over x dx. The 5 is gone, we put a 1 there. The 4 is gone, we leave the x. Then we do the same thing with the 9/4. And we have an empty space left. So what I did here is property number 2, which says fractions can be, or numbers can be separated from integrals. So at this point, we're ready to do the antiderivative of 1 over x. That one is its own rule. It's called natural log of absolute value of x. And then we have the 9/4 with the antiderivative of nothing. So that becomes a 1 when there's nothing written inside the integral. That's a 1, and the antiderivative of 1 is going to be x. And don't forget the plus c. So at the end of the day, this is just 5/4 ln of absolute value of x plus 9/4 of x plus c.